we'll have to do a couple meetings and find the right audience.
Yeah.
It's just, it's the way it always is.
This is saying it's waiting for something. Like when I go to the YouTube page, it says waiting for April. There we go.
Oh, is it working?
Mm-hmm.
There we go. This is it. Very low production value. Okay. All right, so welcome to the tour of industrial automation. This is the first kickoff event for Built in Detroit, a project I started. My name is Adam Cook, and we are doing this event in collaboration with the Society of Manufacturing Engineers, Chapter 153, and they're out of Los Angeles County. At the end, we'll have an event forum where people can submit their name and feedback. But for now, we'll show this at the end. But anyway, here's me on GitHub. If you're not familiar with it, it's an open source software platform, social network. You can read about me here on Motor City Adam. My experience is I'm a Purdue graduate and in Purdue engineering graduate, and I have worked in a CNC shop. I have worked in a press shop, making press machines in a company that no longer exists in South Chicago, and resistance and electron beam welders. I've designed and built those myself. So that's kind of my career experience today. I used to have a company in Dallas where we designed industrial automation. I sold that company. Now I'm basically just doing contracting work, custom robotics, mostly these days. And so, generally speaking, that's the domains that I'll be speaking about in terms of projects and events and workshops in the future. So, I have two presentations today. I won't be talking that long. We'll do one introduction presentation, since this is the first time. Some food will come. We'll do a break, and then I have another shorter presentation. I usually don't do more than 10 slides. After that, people's eyes start rolling in the back of their head. But very, very introductory, assuming no prior knowledge, and that's the way it'll kind of be for a while. In Built in Detroit. But we will get advanced someday, but not today. built in Detroit. We do have a website. There's a QR code at the end. It's nothing fancy right now. In time, we're going to make it real fancy. But right now, it's just a repository for all the events we'll have. One-stop shop, built in Detroit.today. And you can see all the events we have coming up on there right now. But in time, it'll have more information. I'll talk a little bit more about that. But I used to be chair of the Society of Manufacturing Engineers Chicagoland chapter, and in that role, you could really tell that the manufacturing engineering space has a lot of work to do to upskill, in my opinion, younger generations into the field. And there's some debate years ago whether or not that was worth it. A lot of people, we lost a lot of manufacturing in this country. A lot of people went to service jobs and such. And now there's a big initiative to bring a lot of it back. Battery manufacturing, clean energy, automobile production, aerospace. There's a lot of activity out there. Consequently, a couple days ago, Wall Street Journal ran this headline: Gen Z is becoming a tool belt generation. A lot of younger generations are shunning college education to go to the skilled trades yet again, in my opinion. Really sort of validates built in Detroit from a justification standpoint. I think there's this, and then I saw this on Hacker News last night. If you're not familiar with it, it's sort of a posts for tech people. Silicon Valley spends a lot of time. So how can I learn more about manufacturers? There's a lot of hunger, I think, for this information. And you could see that, if you went to this link, you could see all the sort of frantic replies, but not a lot of great information for people. There's not really a North Star. There's not really a place where people can visit, get support, understand manufacturing. You could either go to skills trades to college, but there really hasn't been in the manufacturing sector, I would say, as there has been in the software sector, was sort of open source, collaborative, supportive. It really hasn't been that same thing in the manufacturing sector. So that was what I was working on in Chicagoland. That's what I'm bringing over here now to Detroit. There really needs to be some middle ground, some community effort between the trade schools and the colleges and nothing at all, So I really do think there's a hunger for this. And, part of the issue, and this is not a slam, there's reasons for this, but there's too much is locked behind paywalls and walled gardens. There's too much information that's locked up. And what we want to do is free a lot of that. We want an open source, open, accessible place that people can get information. Maybe to just see if they want to continue on. Maybe they're working on a startup that's making physical product. Maybe they're just interested. Very few places on the internet these days for that kind of. You want to learn Python programming or something, tons of resources. Just overflow of resources. Even on YouTube, there's some stuff scattered around, but it's not as vibrant as the software ecosystem. So we'll never be able to fully compete with sort of industrial corporate training, but we want to find that middle ground and really take it to the next level in an open way. So there'll be two types, I would say, of events that I envision for this. And we're sort of here right now, we're sort of just in the regular event presentation space. In the future, there'll be research discussions We'll have show and tell, and we'll be doing a lot. I plan to do a lot of open source CAD, open source programming. A lot of the platforms and tools for industrial automation manufacturing are proprietary. And it'll always be that way, but there are elements of that we can do open source programming around that I think can be adoptable by people starting startups that are just getting into this. They can write the software so that they get experience in writing software in an industrial setting, and they get experience with the topics that underlie that software. So we will be, these are like 1 to 2 hour events like I'm doing now. They'll be like a mixed bag. And then from that, hands-on workshops is really the key. This is the brass ring. This is where we want to be. I think the biggest problem with any sort of professional organization, any sort of effort, is, and this is why industrial training is so, it's sort of locked away inherently, because there's physical aspects of this that are difficult to put in a classroom setting. Not impossible, and we'll see some of that. Not impossible, but there's aspects of this that are difficult to put in a classroom. If you want to do programming, everybody just needs a laptop. If you want to do electrical maintenance, we need something more. If you want to do CNC program, we need a simulator for everybody. It's a little difficult, but we'll get there. I guarantee it. But yeah, this is really the crown jewel of the whole thing. We need to get to that space where people are actually putting their hands. There's nothing like it. And it won't be equivalent to like working on the job, but it'll be, again, a bridge. We want to make that bridge to something. And of course, the two will feed off of each other eventually. So there'll be classroom time, hands-on, classroom time, hands-on. Hopefully, too. So I kind of talked a little bit about my expertise. I don't know everything, of course. In time, others can participate as well. Once we get down the format, once we get down the areas that there's a lot. There's a lot of experience in the Detroit area in manufacturing. I sort of want to capture that too. It shouldn't be an Adam Cook show. I would open up the floor to anybody that wanted to do something. But for the initial time, I'll be doing it. So, in terms of categories of topics, there's actually some that are hidden, and I'll show you next slide. But mechanical design, industrial computing, fluid power, machining, and robotics are the topics of the year, this year. And of next year too, but these are the focus areas of this year. And it will have an event on each this year and a workshop for a couple. Next year will be even more ambitious. We'll be doing these as well. System safety, electrical systems, forming, molding, optics. And we'll have workshops and events on these too. Some are more challenging than others, but I can talk about all these, certainly, but again, in time, hopefully, we get more people collaborating in this that can talk deeper on some of these. But these are the main categories. But certainly these at the top this year we'll be talking about quite a bit. And again, if you're on YouTube or something and you don't know exactly what I'm talking about, we will get to it. That's going to be kind of a theme the entire time. I've made these presentations sort of high level right now, and we'll nibble at it, and we'll get to an advanced level in time. So, upcoming workshops, the ones I have planned for this year is machine design with Onshape at Fusion 360. So this will be workshops are going to generally be 2 days, 2 full days, Saturday, Sunday. And we'll see how that goes. And for this one in particular, we'll pick a design. I think it'll be a linear slide assembly. If you don't know what that is, let me. If this thing will behave. So I'm using CAD, Onshape CAD, which is free so long as you. See if this pops up. So I've pre-done this, if it'll load. I've pre-designed this. This is mine. It is freely available, so Onshape is free so long as the designs can be accessed publicly. So you can find me and but I've designed this up. It's an example. It's not. That's a linear slide assembly. What we would do is we would knock out 2 birds with 1 stone, essentially. Learn CAD and learn the fundamentals of creating this. At the end of the day, after some time, if I've done my job right, you should be able to design this without me anymore. This and much more related to this. Everything about it, sizing the ball screw, the motor, how all this works. In Fusion 360, how to manufacture it, what your options are, what the trade-offs are, everything from start to finish. Not just CAD, but we want to learn something at the same time. It's a tricky balance, but I'm committed to trying it out. But yeah, that'll probably be the first one we knock out with that. Onshape will do the CAD, and since Onshape yet doesn't have what they call a computer-aided manufacturing module, we'll use 360 to do that part of it. But that'll get a good chance to knock out CAD training, a little bit of mechanical design, and an introduction to manufacturing. All 3 of those have to work together in order to have, all 3 and more have to work together to get Python programming for manufacturers. Okay, so this kind of gets away from into the software, purely software realm. There is a lot of Python programming materials out there, a ton of it. But what part of that is specific and helpful for manufacturing? Can we look at 2, 3, 4 applications using Python programming to accomplish something in a typical manufacturing floor? That's less talked about. So you learn Python at the same time while actually understanding how you can deploy Python to solving real world problems. So, everybody's not gonna, it's a grab bag. Not everybody's gonna respond to all this equally. Some people love designing robots and automation systems. Some people just like to program software. I think you should have it all in, at least a casual understanding of it all. But at the end of the day, it's up to you to decide what you want to take away. And then PLC basics, maybe. We'll see. Gonna use TwinCAT. Beckhoff system to do it. We'll see if I can get some trainers put together. We will be building our own trainers. Committed to doing that, which we will probably do in Onshape together in a workshop. And then once those trainers are built, we'll do a workshop on that. Some people will like to design and build the trainers. Some people just want to use it to learn how to program PLC. And then we'll do motion control and safety, PLC safety, we'll do the whole thing after, but maybe this year we'll have to see how that goes. But that's kind of a preview of what's coming up. In the summer, we'll probably do the workshop for Onshape and Fusion, maybe at the beginning of fall, Python programming, and we'll see about that guy at the end. Manufacturing how? I will have a lot more to say about this platform. If you go to that link, you will see a very rudimentary website, basically a blog. In time, it will become a sort of Wikipedia of manufacturing knowledge. Articles that are interactive, animated, highly visual, prioritizing visual education over text. They will be able to play with 3D models right there in the browser, wiring a PLC right there in the browser. All that will be there. We will have to, together, write a ton of software to do it. But eventually, this will be the Wikipedia of manufacturing. That's what that'll be. And in the future, there'll be an article posted there, a highly interactive article posted there, and we will turn that into an event where people can ask questions and we'll expand upon that. So this is nice too, because I think when I look out again at the internet, there's information's kind of scattered around. Is it reliable? Is it not? You know, it's not very helpful in a lot of cases. Sometimes it's just flat out wrong. Especially I see like in the EV space, the automotive EV space. There's really a ton of really bad manufacturing information out there about that. It's really quite shocking to see, and I think it's because a lot of people that aren't familiar with the industry sort of write their own sort of myths and articles and blogs about it. It's really bad information in a lot of cases, and I see it constantly on social media as people really don't get, you know, how the industry works. And it's not so much like the manufacturing industry has to go back to the Stone Ages. It's more like you need that foundation of actual competent knowledge before we can really talk about advanced topics. So next time, the next event in May, which I will announce today, RSVP's opening tonight, I will be talking against this platform. We'll have an actual article prior to the event, so people will know what's coming, and we'll have a better conversation space to talk about this topic next time. So again, a very light, going a little deeper than today. We're going to get into programmable control, high level history, high level how it looks, what the components are, what the programming languages are, little bites more. And this will really be the basis for future hands-on workshops for PLC programming. If you don't really know programmable control, it's kind of hard, I think, to work in a factory setting in a lot of roles. I mean, it can be quite fundamental, I would say, to the modern factory. So we will be spending a lot of time on that channel, but this will be the next little nibble at it on May 11th. So if you're part of the meetup group, you'll see that land tonight. That'll open up. Okay, so that's it. I was hoping the food would be here by now, but it's running a little late. That's okay. We can do like a partial. But this is the homepage again. if you missed it the first time around. Again, pretty basic, but I got a lot of plans at the homepage that are, I think, really spectacular. It's my experience that if you have kind of a normal looking web page, which is fine for today, but in time, if you have something that really pops, you can do a lot with the web browser these days. I don't know if you got, a lot of 3D modeling, a lot of interactive experiences, a lot of stuff like that. We want to explore all that. We want to make manufacturing exciting, competent, but exciting, particularly for people that aren't familiar with it. It's needs to be very highly visual, interactive, less me talking, more here's how it looks, how can I play with it, how can I actually do something useful. Sometimes this is just enough to give people that are kind of interested in the field but aren't sure. If you show them the end goal, if you show them what they're working towards, it really motivates them, I think, to keep with it. And that's really what you want. So I will start up the next one, which will also be short. This is the main event. So, tour of industrial automation, again, very high level. In this, I create a lot of my own conceptual models about how the industry works. It's very simplified. If you're experiencing the industry, it's going to be too simplified. But I think if you're just coming into the industry or you're not that cognizant of it, especially a lot of the stuff we talk about in Built in Detroit is going to be for high schoolers and up. That's really the area. High schoolers kind of trying to find their way. Do I do trade school? Do I do college? Do I do a little bit of both? What do I want to do? I think for that group, they can understand a lot of this information, but they've never seen a factory floor. They've never seen a robot. They don't know what a tapped hole is. It's very basic. So, in some ways, I think for experienced people, it's going to move too slow. But for people that are just beginning, I think we'll find the right tempo before long. All right, so a brief history. This is probably on every single industrial automation slide deck in the world, but we'll run through the sort of versions of industry as they've evolved through the years. Really starting with the 18th century here, first industrial revolution. There were mechanical systems that were steam driven. Oh, food time. Let's do a break. How about that? And we'll come back in, thank you, I appreciate it. And we'll come back in 20 minutes and we'll finish this off. This won't take very long. So,
And check.
All right. So, the second portion, which will be roughly the length of the first portion, is tour of industrial automation. That's why we're all here. Very basic, again, like I said before the break, very basic, high-level overview of two topics, really. The factory floor itself and the manufacture of product, depending on what it is, can get very complex. And we'll talk a little bit about that. But today we're just going to kind of talk about the top. In time, we will nibble down into more complex topics, more domain-specific topics. I do have something fun to show on YouTube, and we'll, what I should do. All right. So, here we go. Industry, we're going to basically walk through the different versions of industry. Some people call them revolutions, industrial revolution. Really, it all began with Industry 1.0 back in the 18th century, roughly, when people discovered machinery, metal machinery, steam-powered systems. It was really the first time that humans stepped sort of into production, automated production. Not really automated yet, but mechanical driven production of physical product before it was all by hand. And this enabled a step change in productivity for humanity, basically. And so that was the first. Then came along Industry 2.0, which I submit built Detroit, essentially. Embraced electrical power, production lines, mass production, still very basic, but it was another step change in productivity. And it brought a lot of wealth and it brought a lot of productivity into society in terms of mass manufacturing, parts and production and equipment. From, let's say, a little after World War II, we kind of came into like the third industrial revolution, which is you started embracing programmable control on the factory floor to automate production processes. So this was the first embrace of sort of what we know today as industrial computers to run production processes. There started to be robotics emerging here in this area, machine vision, some rudimentary machine vision. Again, another step change in productivity for industry. Probably the fruits of this industrial revolution, if you watch any YouTube video about manufacturing robotics, excuse me. If you watch any videos about manufacturing robotics, if you go to a trade show, if you see a lot of the fruits of this, a lot of robotics, conveyor belts, factory floor, just equipment scattered about it. It sort of nibbled at the human labor portion of it. And then we kind of came across to the thing we are now, which is the Industry 4.0, depending on who you ask. We are here now, which is really leveraging sensors and data to develop a closed loop production process. It's I tried to find the right language here to describe this if you're unfamiliar with it. This one is tricky because I think a lot of people in industry aren't here yet, but a lot of people want to get there, especially in the small and medium manufacturers struggle with this a lot to justify it a lot of the large manufacturers. So you basically decorate your factory floor with sensors and your product potentially. And it's constantly streaming data about the healthiness of your factory floor, about the healthiness of your product. And the way it's supposed to work is all that information is supposed to be collected and analyzed, some of it automatically. And that's you're supposed to take that information in sort of a real-time sense and refeed it back on your factory floor. And it's supposed to make for a more optimal product. In the foreseeable future, we will be focusing on these two here. These kind of come along with the ride, but we'll be focusing on mostly modern interpretations of manufacturing. But this will be a big thing, I think. Again, I think depending on who you ask, I think depending on the factory floor, the company, the adoption of this has been a little bit more uneven than it has for the third industrial revolution with robotics and stuff like that. But probably even back then, it was a little tricky to get people up to speed. But then we have Industry 5.0, which is sort of a brand new term that people are trying to sell you products and services. It's sort of supposed to be sort of leveraging artificial intelligence to do this, what you did here, in a sort of a very automated way. I don't think we're anywhere close to this. As much as the hype train is out there for artificial intelligence these days, I'm pretty thinking this is not in the near term future. But we will in fact talk quite a bit about artificial intelligence and deep learning in particular. In particular with machine vision systems, which is something that I do a lot these days. So I will be teaching people how to do that in another workshop. I haven't really thought about the workshop yet, but we will have a machine vision system, I envision, and we will be doing deep learning for defect identification, which we do now in industry now. There are machine vision systems that do, but that there are new opportunities now, new technologies that have been developed that can go a step further, and sometimes the results can be quite surprising. It's not Terminator style artificial intelligence, like again the hype train makes it out to be, but it is powerful stuff. And while we want to, in Built in Detroit, sort of ground the educational experience in very practical matters, we always want to keep one eye on the future, and I believe in that a lot. So anyway, so if we, at the bottom here, if we have a factory floor, just an arbitrary factory floor, I submit, and this is a very simplistic model, other people have different breakdowns of this, I submit there's a couple things that describe it, essentially. Sort of a layered cake down to the factory floor. At one layer you have machinery and robotics, a very sort of tangible thing, the actual machinery and the robotics that are doing useful work. Right? We have programmable control, which is not only controlling the robotics and the machinery, but actually the aspects of the entire factory floor around those machines. We have industrial networking, which enables all these machines and controllers to talk to each other, potentially in the factory floor and internationally, if you have multiple factories. And there is a number of protocols and wireless and wired technologies that are specific to industrial automation that differ from sort of the the general computing IT world. And we'll talk about that in time. There's skilled human labor, which is essential in every factory floor. Welders, machinists, you name it. And that's still going to be a very vital part. Maintenance for the machinery itself. These are very vital components for the foreseeable future of a factory floor. And finally, have the manufactured product. Okay, the reason that all of these are the same color is because at the end of the day, and I think the next slide will kind of go into this a little bit more. At the end of the day, what makes a great, competent manufacturing engineer or somebody involved in manufacturing is able to understand bits and pieces. It takes experience. It takes time. And again, I hope Built in Detroit sort of surfaces this for each of these layers, at least somewhat, to understand the roles and the trade-offs of all these systems together. Whenever you're going to launch a new product, whenever you envision a new product, whenever you work in CAD to design something, whenever you're on the factory floor itself, if you understand a lot of these, if you have competency, at least a baseline competency in a lot of these systems, you know your product, you know what your labeler is capable of, you know what your options are in the machining and robotics space. If you have that in your mind, that makes you a great engineer. I think a lot of people get focused on like one aspect and they kind of have horse blinders on and they don't know the whole thing, and that limits your potential in terms of understanding a factory floor. And so a la carte, we hope to eventually have anybody that participates in Built in Detroit or reads the Built in Detroit content will understand each of these layers, at least at some level. Of course, for the near term, we're going to be doing robotics and machinery and programmable control. But actually, I do have a industrial networking session for June, I think, but that's to be announced. You have to think in systems. So this goes back to what I just said. This is the best way I can describe it. You have to think in systems. Again, people get too novices that come into the industry tend to get too focused, I think, on one aspect of it, and they, how can I program this robot, or how can I design this part? But they don't. But there's layers above that. There's systems above that you need to understand to really optimize a factory floor, to really optimize a product, to really create a quality product at high volumes. If as the case may be, you need to understand the systems, the interacting systems of the factory floor. And these are difficult to conceptualize because they're mostly intangible. There's very intangible concepts, so they're not physical. And if there's one takeaway in any event that we do from here on out, it's to understand systems, and trade-offs are extremely important. You really, I don't know how to describe it any better, but if you look, there's, again, as I mentioned in the first presentation, there's a lot of people coming into the field, I think, from sort of a tech mindset, and they're saying, I'm going to create this fantastical robot to do all this stuff, a humanoid robot, and we'll have a little discussion about that. A humanoid robot to simply replace human labor, and it's just going to be that easy, But there's no knowledge of trade-offs because you don't know. If you don't know the trade-offs, then the discussion becomes very shallow at the end of the day. Very inexperienced, very very novice, and you're going to walk right into a buzzsaw with it. what robots do I use? You know, what's the trade-off of each of these robots? What's the trade-off of each of these systems? You know, what's the pros and cons? That comes from experience. That comes from being supported by people that know, have worked in these industries, and then pass the knowledge on to you. But that takes a while to develop that sense of systems and trade-offs. And once you get that, once that clicks, it's very essential. I do think that's kind of a fatal flaw with a lot of industrial training out there. It doesn't, to be fair to them, it doesn't have a lot of time to do this stuff, and we're hoping to create the time here. But there's really needs to be a more systematic, more trade-off discussion about that's really the meat and potatoes of the thing. From that, you can get into the more interesting stuff, and you can do it very competently. But yeah, this is a real, personal to me, this is a real fundamental principle. So, I'll just go ahead and show the whole thing. This is my breakdown of the robotics field. I have designed custom robots for this linear robot. It moves along linear axes, straight lines. I have a video I'll show some videos at the end here on YouTube of what I mean by this, but it works in the X. Some of them just work in one direction, some two directions, some three directions. Linear robots, articulated arm robots are the ones that you're probably more familiar with. You see them if you look at any typical car factory, trade show. They have multiple joints, and they're very popular for very flexible work in terms of cell and deployment. Then you have more specialized robots. I consider them more specialized: a Delta robot, Scar robot, mobile pallet robot, a co-robot, and a humanoid robot, which is, I'm hesitant to put this one on there, but I did put it on there. There is a lot of hype these days around this one. But again, I think that people aren't understanding the trade-offs, again, with something like that, and they are, which again justifies, I think, in my mind, built in Detroit. People are interested in manufacturing, but they have a very interested in robotics and manufacturing, but they have a very shallow understanding of it, and that tends to create hype, and it tends to create flimsy discussion and knowledge, and I don't think that's a very healthy way to proceed. But let me pull up this one here. We can talk about it just a little bit. We got time. So it's got 2 million views. Maybe you've seen it.
Hey, Figure One, what do you see right now?
I see a red apple on a plate in the center of the table, a drying rack with cups and a plate, and you standing nearby with your hand on the table.
Great, can I have something to eat?
Sure thing.
Great. Can you explain why you did what you just did while you pick up this trash?
On it. So I gave you the apple because it's the only edible item I could provide you with from the table.
Great. So, based on the scene right now, where do you think the dishes in front of you go next?
The dishes on the table, like that plate and cup, are likely to go into the drying rack next.
Great. Can you put them there?
Of course.
All right, so how do you think you did?
I think I did pretty well. The apple found its new owner, the trash is gone, and the tableware is right where it belongs.
I agree. Thanks, Figure One.
You're welcome. If there's anything else you need help with, just let me know.
All right.
Belongs.
So, this got 2 million views, and of course, if you look at the YouTube section, everybody's talking about near-term availability of a Terminator-like robot that will may doom us all, but will replace human labor. Where we want to get in this, it may seem like a contrived example, but when I saw this the first time, it really, again, justified to me why Built in Detroit exists. There's a lot of people looking at this and seeing a robot that looks outwardly impressive. Is it impressive engineering? Yes. Is it anywhere close to replacing human labor? No. Not even close. And you have to understand why that is. I think people that are experienced understand why it is, but I think to a lot of people that don't have educational resources around robotics, they don't know, again, systems and trade-offs. I mean, just look at the complexity of this robot. Just imagine maintaining something like this. I mean, it's a demo as it is. It's a demo as it is. So you really don't know exactly. I mean, they're implying that he's speaking to the robot, he's taking that information, running it through a neural network, and issuing motion commands to this robot to do useful tasks. That's what they're claiming and doing. Now, I'm not saying that's truthful or not, but it is a demo. And you don't really know that that's exactly what's happening. You don't know how this thing was trained. You don't know if there's somebody teleoperating it somewhere else. But even all that aside, I mean, just look at the complexity of it. Look at and the real question is, at the end of the day, humans operate in a certain domain. We have a muscular skeletal system to do that. We have a nervous system to do that. Those two things and the intricacy of those two things. If you look at this robot's hands, it doesn't have an inner palm structure. I mean, just minor things like that. I think people aren't understanding that if you have a simpler representation of a human, which this very much is, its domain is now constricted from what a human can do. And so you have to think along those terms. You have to think about the domains and systems and what are the trade-offs of this robot, because people are jumping on these sort of hype trains. So there's not only the lack of knowledge out there, but now people are making it worse, in my opinion, by jumping on hype trains that get even further and further away from competent robotics education, competent manufacturing education. And so I saw this a couple weeks ago, and that's exactly what I had in my mind, is that there's a lot of problems with this. But people are already talking about replacing human labor en masse. And I think there's a lot of negative effects at a societal level to that kind of thinking, where the public is less educated about how manufacturing works, And there's policy ramifications for something like this, you know. And so we're not a political organization, but there are political dynamics to this sort of, I think, flimsy public knowledge about these systems. And it will become more pronounced as time goes on. There's a lot of people that weren't interested in robotics, maybe even just last year. Now are trying to get into it. But anyway, so that is a more forward-looking thing. This is for those who do not know, a linear robot. You saw just a piece of this when I pulled up Onshape. You can see the linear, in this case it's a belt-driven robot. But you see, it moves along linear axes. This is a relatively common but slow robot. There's some that are very fast. And they populate circuit boards, little tiny components of circuit boards. So fast, it's difficult to see sometimes. And then you have ooh, they got loud.
Solutions have been facilitating industrial production for over 60 years. FANUC is present in 120 countries, including Hungary, assisting key
Robots with
sectors
multiple
like the
joints.
automotive industry.
And I have
For
designed
example,
quite a few custom
Bulgaria
ones of
built
this.
a limited factory
They're not as streamlined
developing a manufacturing
as
Audi AG and the Volkswagen Group.
Fanuc's robot is a major manufacturer of these.
Companies with the largest turnover
AVB is another one. KUKA,
producing 2 million engines and 100
very flexible robot. Flexible in terms of the tasks it can accomplish. Flexible in terms of redeployment for different tasks later.
We are constantly
So,
improving our production and install robots to reach out.
We will, in fact, eventually design our own robot. It will be simpler than that, but it will hit everything they're using internally. Again, it provides a good basis for CAD education, manufacturing principles, and a real deep understanding about how this robot works. And we'll do end effector design, so the actual grippers, or you can see the tooling on the end of this that actually does the work. There's a whole industry around that too. And again, we'll be doing very simple stuff, but we'll be doing enough to understand how that sort of industry works and how you might approach that. I think for now that is enough, because before the next meeting in May 11th, I will have a manufacturing how article on all these robots, and we'll go through the various trade-offs. We may, in the next meeting, circle back to it. I can't promise that, but we may circle back to the article. But that's the point. Is we want to. This is a very brief presentation. In the future, we're going to have more detailed presentations that talk about these. Particularly in the workshops, we'll go deeper down into these things. I think PowerPoints are a poor proxy for that, but. So, 2 more slides and that's it. Programmable logic controller, dedicated, an industrialized computer. The way I describe it is it's dedicated hardware, it's industrialized computer, dedicated hardware to perform relatively simple tasks. And that's not very true these days, but in the beginnings of a PLC, very, I would say, basic logic control. Someone presses a button, it turns on a light. Something comes across a conveyor belt. Is some other machine over here sees that and performs some tasks. So, open, closed, very logical programming. Nowadays, it's not as clear a boundary anymore, but it used to kind of be. We have programmable automation controllers, which we will be, that contain sort of the same PLC module. They can do logic control on the factory floor, but this controller is really just a basic, I shouldn't say basic, it's really industrial PC, like if you use Windows, if you use like a Windows PC. It's basically the same thing, but they've ruggedized the PC for industrial use. And they have also created modules for this that are specific to performing industrial tasks. So instead of the very basic sort of programmable control that we used to be sort of contained within the PLC, nowadays we have something that really looks like a computer and can do data analytics and can use programming languages like a regular PC. And it opens up a whole new realm of possibilities. For some factory floors, it opens up a whole new realm of possibilities to do, again, data analytics, to do machine learning, to talk to internet systems, IT systems in the office, far more. Now that's kind of not becoming true. The PLCs are evolving to do motion control, to do CNC control and everything, but this is generally correct. And what we will be working with, what I will be talking about most is TwinCat, which is a runtime platform programmable automation controller company that basically does the purple square here and picks up the blue square at the same time. So there's a lot of functionality in there that we'll walk through over time. And I would say once you know TwinCat, this platform I'm talking about, once you have some good experience with it, you could take that knowledge and generally apply it to other controller platforms and products. But this will be taken apart in various workshops. And here I just put in the programming languages that I will be talking mostly about for programmable logic controllers. There's a very illustrative programming language called ladder logic, and it basically looks like a ladder. But and I will talk about it and I will show it in the meeting in May. But this is a very popular programming language for PLCs, and we will spend a lot of time on it. There's also another popular one called structured text, and we will talk about that too. These, if we go up to the programmable automation controller, we can see these, which if you are familiar with computer programming, these should seem familiar. And I do know Beckhoff supports at least these two, and I think there's a community supported APIs for Python. And we will be using all three of these programming languages in our TwinCat workshops. Really all these. We'll be going through all these. And once you got these down, it'll take a while. Once you got these down, you can transfer these skills pretty readily to anything else. But there are to do this.
This is the SoftTech Motion Trainer. It allows you to learn TwinCat motion control.
We will be building our own of this.
Wherever you are.
I built a few when I was in Chicago that were custom for our class, but we will be building. Oh, that
This
was.
environment is meant to be a safe.
So you can see the Beckhoff PC here, the PAC. They have various modules that they add onto that, input output modules. They have two servo drives here. They spin. and they have a power supply here. And basically, you hook all this up to a Windows PC, and they have a programmable environment for Windows, and you can program in Windows, and then you push it down to the PC, and then you can see the results on an actual hardware device. And these can get quite exotic, and we will get quite exotic in time. But this interacting with this hardware is essential, and a lot of students got a kick out of working with that, with their hands. Once you see it, it becomes a lot more relatable. But just something to look forward to. But well, I think that's it. Really short and sweet. Again, the QR code to our website is here. And go back to this one. For those in physical attendance, we do have an event form. You can either do it at home if you want to scan that with your phone. Very basic: name, email address. Feedback is important. There's going to be you're not going to offend me. I don't care what it is. You don't like my shirt. You don't like me. I don't care what it is. Tell me about it, and we'll adjust for next time. It's going to take some time. It's going to take several months of learning to understand. We're learning on the audiovisual side. We're learning on the presentation side. We're learning what people in this region respond to, like to see. We're not going to get it right every time. Definitely not. This was a little informal, as you can see. We will have more formal presentations in the future. We'll have more informal ones like this, and we'll have workshops and all that. I want all the feedback for that. So if you don't like something, we can. I think as time goes on, like I said, once the manufacturing how platform gets a little bit more advanced and it gets a little bit more visual, I think people will have feedback there. And I think once they can kind of interact with it at home, it's my experience that once they're in the comfort of their own home, they find areas where they would like to explore more. But they need the tools in their hand first. And we don't have that today, but we will get there. So you can either do it online, or I have an iPad, but you can do it here if you want. But yeah. So thank you for coming. I appreciate it. And is there any questions on the live stream? No? Okay. Great. Thank you for coming.
Thanks for having us.